Okay, so the notes today, we decided on green, yeah. So the notes today are 7-4A. It's about exponential growth translations. And it's just translations, not all of transformations. So what's the difference between translations and transformations? Right, translations is shifting left and right, up and down. Transformations involves things like reflections and vertical and horizontal stretches and compressions. Yeah, stuff like that. So this is just shifting today. Just shifting. And remember, exponential functions, the parent function is f of x equals b to the power of x. And what does b represent? The what? Base. Thank you. Represents the base. And in our functions today, b is going to be greater than 1, which means that we're going to be dealing with exponential growth or decay? Growth. So all of our functions today, ooh, that looks like growth. All of our functions today are going to be representing exponential growth. They're going to be increasing from left to right. And our parent function has a base b raised to the power of x. We have 3 examples here. The first one is f of x equals 2x. The next one is f of x equals 3x. And the last one is f of x equals 4x. So I want you to take a moment and kind of scan these 3 graphs and tell me some things that you see that they have in common, other than the fact that they're both going up. They're both growth. What do you see that they have in common? The what? The y-intercept. The y-intercept is the same on every single graph, right? 0, 0, 1. And didn't we talk about that on the day that we did our parent functions? We created a table. I don't know if this is going to fit in the recording, but we created a table, and the table had like a bunch of numbers for x, a bunch of x values. And if I substituted those x values in there, if I took 0 and I made it the exponent, 2 to the power of 0 is always going to be what? It is not. It's not going to be 0. It's going to be 1. Anything to the power of 0 is 1. 3 to the power of 0 is 1. 4 to the power of 0 is 1. Tiger to the power of 0 is 1, right? Anything to the power of 0 is 1, which is why we end up with this in our functions, our exponential functions, unless it's been shifted, which we're going to do today. So we see the y-intercept is the same in all of the functions. What else is the same in all of the functions? The asymptote, the horizontal asymptote, right? What is the horizontal asymptote in each of these functions? Y equals 0. Yeah. Every single time, y equals 0. So those are going to be 2 things that we look for in our functions today. We're going to be looking for the horizontal asymptote, and we're going to be looking for that point that's just above, one above the horizontal asymptote. Those are 2 big things that are going to help us determine how the graph has shifted or how the graph has been translated. Okay? So I'm going to move this to the next screen. Can I change it? Okay. All right. So the first thing that we're going to discuss, and we'll go back to the first screen in a minute, but the first thing that we're going to discuss is horizontal translations. So if you translate horizontally, like let's say you shift to the left 3 spots, where's that going to show up in a function? If you shift to the left 3, in the parentheses with what? With x. Which means it's a lie, that's right. So if I'm shifting to the left 3, then what am I going to have in parentheses? X plus 3, I'm going to be adding 3, good. So these are all good things to remember, but also remember that your function for exponentials is f of x equals b to the power of x. So if I'm putting like plus 3 in there with x, x is an exponent, isn't it? So it's going to end up being in the exponent as well. Because if you shift to the left or to the right, whatever you shift left or right has to go in parentheses with x. Do you agree? Well, x is an exponent, So whatever you have shifting left or right, that's going to go into the exponent as well. So if you have x minus h as the exponent, that means that you're shifting to the right. If you have x plus something in the exponent, that means you're shifting to the left. So again, everything in parentheses is a lie. Shifting left or right is in parentheses with x. It just happens to be that x is an exponent. So let's write the equation of each transformation. Let's talk about those horizontal translations. The first thing that you're going to look for, number one, is you're always going to look for the horizontal asymptote. That's item number 1 on your list, and you do need to find somewhere to write this because this is important. You always want to find your horizontal asymptote. So in example 1a, where's the horizontal asymptote? Y equals 0. It's right here. Horizontal asymptote y equals 0. Which is where it's supposed to be based on the parent function, right? The parent function also has a horizontal asymptote of y equals 0, so it's in the right spot. However, the next thing that I need to look for is I need to look for 1 point above the horizontal asymptote. So do you remember how in our previous little slide we had this point right here that's 1 above the asymptote, 1 above the asymptote, 1 above the asymptote? Do you remember that? Okay, so here, that's what we're going to look for again. So we're going to go look for the point that's 1 above the asymptote. Right here, correct? It should have been, yeah, at 0, 1, but now it's over here at 3, 1. So how many places did it move? 1, 2, 3 to the right, which means that the h value is 3. I agree with you. So I want you to take a moment to try part B. All I want you to do, and I know we're not finished with part A. We don't have this, we don't have the function, but what I want you to do is identify the horizontal asymptote and find the point that's 1 above the horizontal asymptote so you can determine if it's shifted left or right. So take a moment to try and do that. I'm going to pause the video. Yes. Okay, so in part B, I need to find the horizontal asymptote, so can I get a volunteer to supply the horizontal asymptote? Yes, ma'am. Go through all the numbers and then you'll eventually get it. Yeah. Can you give me the equation for that? Not just 0, but what equals 0? Y equals 0, yeah. Awesome. Okay. I also need the point that is 1 above the horizontal asymptote. So can I get a volunteer to tell me where that point is? Yes, ma'am. -4, 1. You bet. -4, 1. And it was here on the parent function, but it's now been shifted to the what? To the left. How many times? 4 times. So if it's gone to the left 4, what is my h value? -4. -4. So it seems pretty simple to put those pieces, those h values, into your function. So when you start writing your function, it's a function. So what do you start with? F of x. Y'all are getting good at that. Do you know the b value? No, you don't. But you know the exponent, right? What's the exponent if this graph we've shifted 3 units to the right? What's the exponent going to be? X plus 3 or minus 3? Minus 3, because everything in parentheses is a lie. So that's the exponent. Same thing with this one. We know what the exponent's going to be. F of x equals some b value, some base that we don't know yet, raised to the power of x plus 4. You bet. It's just the base that we have to find, the b value. So I'm going to go to the previous screen, because there's something that we need to talk about in order to get the b value. B is greater than 1, so b is always going to be exponential growth. Anything you write for b is going to be positive and more than 1. But one of the things that we talked about in 7- I guess it was 7-1 or maybe 7-1a in the parent function notes, so we talked about if you have an x value of 1 and you raise your base to the power of 1. What's 2 to the power of 1? 2. What's 3 to the power of 1? 3. What's 4 to the power of 1? 4. So every time you raise the base to the power of 1, what do you get back? The same number, the base, right? B. So would it be fair to say that if x was 1, the y value was b? Yeah, that would be fair to say. And 1 comma b should be on your function. We actually have that here. So if you're trying to find the b value, you need to find the point that's to the right of this y-intercept. I'm going to switch colors again. Actually, I'm going to switch to blue this time. If I go to the right of my y-intercept right here, that intersection is happening right here. So what's this distance? 2. That happens to be my b value. Again, finding the y-intercept, if I go 1 to the right, here's my point. What's that distance? 3. That's my b value. Find my point, go 1 to the right. What's that distance? 4. That's my b value. So we're going to add to our list of things that we need to do. Not only do we need to find the horizontal asymptote, and we need to find the point 1 above the horizontal asymptote, we also need to find the point that is to the right, 1 to the right, of where that y-intercept should have been. So, oops. Find 1 point to the right and count the vertical distance. 1 point to the right and count the vertical distance. So let's talk about A. Am I counting the distance from 1 point to the right from here? Or am I counting 1 point to the right from here? From here, that's right. So if I go 1 to the right, here's my point. What's that distance? 2. So what does that mean? 2 is the value of b. So where does 2 show up in my function? Where b should be, the base, right? There. Let's try it again on part B, and I won't make you do it alone. Do I start from 0, 1 or -4, 1? -4, 1, because that's where my graph has been shifted to. I move 1 to the right. I go find that point. Here it is. And I count the distance from the asymptote to that point. So what's that distance? 3. So the b value is 3. And 3 belongs here as the base of the exponential function. So you have 3 things that you have to check for. You have to first go find the horizontal asymptote. Then you want to find the point 1 above the horizontal asymptote, because that tells you if you've shifted left or right. And then you want to find 1 point to the right and count the vertical distance. That will give you the base. So those are the 3 things that you're looking for. Is there anything that you want to ask before we go on to the next part? Okay. So we talked about horizontal translations. Now let's talk about vertical. If you shift, let's say you shift up 4 units on any graph, where does that 4 show up in the function? After everything, after the x, kind of at the end, right? Just on the outside. That's where it's going to show up here too. So if you're shifting up, you're going to have, oops, plus something on the outside. If you're shifting down, you're going to have a minus something on the outside, so at the end, just where it always shows up. So let's talk about how you know where you're shifting, how far up or how far down. So look at example A. How does this look different from one of our previous questions? It's definitely shifted up. How can you tell? It's way above the x-axis. How can you tell how far above the x-axis it is? The numbers. Yeah, but what are you counting? The distance from what used to be the horizontal asymptote to now what is the new horizontal asymptote. So what's this distance? 4. So 4 is my what value here? K. So you get your K value by looking to see how far your horizontal asymptote has traveled. Really? So that was step 1, find the horizontal asymptote. Step 2 is to find the point 1 what? What did you write down? What was the second thing? 1 above, right? So 1 above, that's right here. That tells you if the exponential function is shifted left or right. Has it shifted left or right? No, because it's still, that point is still on the y-axis. And then what's the other thing we need to find? Go to the right one, count the distance from the axis or from the asymptote? From the asymptote, because that's where you should start. So here's my point. That distance is 2, so that's my b value. So if I were writing my function, I'd start out with f of x equals. Oh no, we didn't. What was the horizontal asymptote? Right here, y equals 4. Thank you. So if I'm writing the function in the form f of x equals b to the power of x, what do I write first? The base, which is 2, you're right. So here's the b value. To the power of x. Remember that things with x in parentheses indicate shifting left or right. Did we shift left or right? No. Our h value is 0, so we just leave it like that. If you wanted to put x plus 0 or x minus 0, that's not wrong. It's just extra and you don't need to put it. It's superfluous. So you just write x. Well, did we shift in any direction? We shifted up. So what do we do? Plus 4 on the right side. Because we did shift up 4. So this is, k is not a lie. K is never a lie, remember, because it's not in parentheses. So I want you to try B. Try it on your own and then compare it with the people at your table, and I'm going to call on some random people to help us with this. So let me pause the video, maybe. All right, so for B, for part B, for graph B, first thing that I need to find is the horizontal asymptote. So perhaps I can get Angela to help me with that. What's the horizontal asymptote? Yeah, and the question has come up, why does it look like it's halfway between -5 and -6? It's just the way that it was printed. So y equals -5. Angela, could you tell me what that means for my values over here? K equals -5. Very nice. We've shifted down 5 units. Awesome. Okay. The next thing that I'm asked to find is the b value. And in order to do that, I've got to go through a series of steps. So perhaps I can get Alyssa to help me with that. So what should I do from here, Alyssa? What first dot? This one? You went to y. y equals negative 4. Go to the right. Go up. You count. How many? That's your value for what? Cool. And the final thing that I need is the function. So maybe I can get the function from Azuli. Of x. 3. To the power of x. And then what? Minus 5. Yes, ma'am. Awesome. Yeah, I know. Yes, ma'am. Okay, so before we go on to the next example, which has the same stuff in it, I do want to talk about domain and range of these exponential functions. When we did our parent function notes, we discussed how the domain, I think this will fit in the video. The domain from the left side to the right side is going from an arrow to an arrow that doesn't stop. So you're right, all real numbers. But the range was different. It was not all real numbers, even though you all wanted it to be. The range was always the y values that were greater than something. It was greater than 0 for the parent function. But on something like this, the range would be all the y values that are greater than 1. The asymptote, which is 4. So the range is all the y values that are greater than the asymptote. So on this one, like you said, all the y values greater than 4. But on this one, what would the range be? The y values greater than negative 5. You're right. So that kind of helps us with the next example that we're going to see, because the last thing that it kind of throws in is domain and range. May I change this? Okay. So we've got example 3, example 4, example 5, and then we've got example 6, which is almost kind of a review of stuff from the last few days. So I'm going to do 3. You're going to do 4 in your groups, and then you're going to do 5 by yourself. And some of you have already gone ahead, but that's okay. So I'm going to talk through 3. You do 4 in your groups and 5 by yourself. So on number 3, I find my horizontal asymptote. That's step 1. It goes through a y value of 1. So my function, my horizontal asymptote is y equals 1. That tells me that my function has shifted up 1 unit. So my k value is 1, a positive 1. I look for the point 1 above my horizontal asymptote, so that would be along this line. So that's right here. It should have been on the y-axis, but it's not anymore. It's been shifted 1, 2, 3 units to the right, which means that my h value is 3. And finally, the last thing that I need to do in order to find my function is to calculate the b value. So the way I get that is I go from this point, I go 1 to the right. Here's the point along that line. And I count the distance from that point to the asymptote. Not to the axis, but to the asymptote. So that distance is 2, meaning my b value is 2. My function always will start out with f of x, but it's going to have a base raised to the power of either x plus h or x minus h. And then we're going to have some kind of plus k or minus k on the outside. So if I start out with f of x, my base was 2. My exponent is x with the h, so I do the opposite, minus 3. And then I have the k on the end, so plus 1. That's my function for this translated exponential function. My domain like all exponential functions, from the left to the right is all real numbers. And my range is all the y values that are greater than the asymptote, and the asymptote is at 1. So that's how I would go through the question. I would find the horizontal asymptote, that tells me my k change. I'd find the point above, that tells me my h change. And I would find the point to the right and count, that tells me my base. So I'm going to pause the video, and I want you, with your group, talking together to find all the pieces and create the function for number 4. Okay, so on number 4, Evelyn, can you give me a piece and how you found it? K equals -5. How did you find it? The pencil test? Oh, like this? Not sure what a pencil test, like a rubber band thing? Okay, so with the rubber band stretching across, where does the rubber band stretch across? At -5. Okay, so what is that called, Evelyn? Awesome. Okay, so maybe somebody can piggyback after on her explanation and give me the horizontal asymptote. Can I get a volunteer for that one? Yes, ma'am. Y equals -5 is the horizontal asymptote. Wonderful. By that little rubber band trick, right? And if you don't have a rubber band, pencils work fine. Okay, I need another piece, either the b value or the h value or the domain or the range. I need that from Anna. The h is -1. Mm-hmm. 1 left. You bet. So instead of being at 0, 1 where the parent function was, you go 1 left. I like it. Good explanation. All in a complete sentence too. Thank you. All right, I need either the b value, the domain, or the range. I need that from Patrick. The what? B or domain or range. Pick one. Complete sentence for the answer. How did you get that? Good. The y doesn't go lower than -5, and y does not touch the asymptote. The graph does not touch the asymptote. Nice. Okay. Either the b value or the domain I need from Alex. I like it. And that was all a nice complete sentence too. And that's totally fine. All right, now I need the domain. The domain's the last piece before writing the function. So I suppose I could take either one of those, but I need either one of those from Abby. Is that the way it's supposed to look?
Oh, no, you're supposed to put it like,
so when you tell me, be specific where these things are going. Okay, so I got the f of x equals 4 to the power of x plus 1, parentheses, and then plus 5. On the bottom? Not as an exponent. There we go. Plus 5? Minus 5. Okay. And then finally, the domain. How about we say that one all together? What is the domain on the count of 3? 1, 2, 3. Don't be so excited. I need you to calm down a little bit. All real numbers, yes. Okay, very nice. I feel like I got answers from all around the room. The last thing that I need from you is number 5, but I want you to try it alone so that whenever you have to do your homework, you have practice doing this alone. Okay, we're going to answer number 5 all together, each piece. So we're going to start out with kind of like the order that you would go in as you're trying to get all the pieces. So the first thing that you would find is the what? The horizontal asymptote. So on the count of 3, I need the horizontal asymptote. 1, 2, 3. -6 is a number. I'd count that wrong. Y equals -6. Oh, do you? Okay, well then let's go to the domain. On the count of 3, I need that. 1, 2, 3. All real numbers. Again, I need you to calm down with the excitement. You're like too early. Okay. Let's go to the range. So think about your range. I need that on the count of 3. 1, 2, 3. Y is greater than -6. That sounded lovely. You're getting the hang of it. All right, the next thing that I'm going to look for is my K value. So I need the K value on the count of 3. 1, 2, 3. I'm sorry, what? Oh, okay, K equals -6. I like it. Number 15. All right, next piece I need is the H value. So I need the H value on the count of 3. 1, 2, 3. H equals 2. We have shifted over 1, 2. Next piece I need is the B value on the count of 3. 1, 2, 3. B equals 3. Good. 1 over. Here's my point. That distance is 3. Last thing that I need is the function. Oh, please no. No. Shh. That's better. Okay. F of x equals 3 to the power of what? X minus 2. And then on the outside? -6. All right, last piece, and we're going to read it together. It says a piece of gold jewelry was worth $700 in 1980. It has increased, growth or decay? Growth, so 1 plus R. It has increased in value over time by 1.8%. What is 1.8% as a decimal? R equals 0.018. That's something that you need to automatically do. It asks what will be its worth in 2020. So how many years have gone by from 1980 to 2020? 40 years. 2020 minus 1980 is 40 years. So what's the initial value of this piece of gold jewelry? 700. What's the growth rate? 1.018. Good, because you added, so 1 plus 0.018. And then the x is the time, so what's the amount of time here? Nice try. 40. So when you take all your pieces, you put them together because I do need to find the worth in 2020. So we have f of x. Okay, so what parentheses? Oh my goodness, it does not matter. So what am I finding? F of what? F of 40 equals the initial value, 700, times the growth factor, 1.018, to the power of the time, which is 40. So if I were to get my calculator out and do that, which look what I have. No, I didn't steal it. They gave them back to me. Goof. All right. So 700 times 1.018 to the power of 40. I assume you would be able to write that down correctly. Should the value have gone up or gone down? It should have gone up because it's growth, right? So 1,428, what is this measured in? Dollars. So how many decimal places do I need? 2. So instead of 0.924, I would write 0.9. Probably 1 or 2 points, yes, because it's measured in an amount of money, yes. The question is, what will it be worth? It will not be worth 1,200 or 1,428.92. It will be worth $1,428.92. Don't forget to box it in. Okay.